Hello friends, so after completing first problem, let's move to the second problem where the right hand side of higher order differential equation is x into some function of v, and guys, this time that function of v is not a simple one. So keep watching this video and see how I have solved this question by using the rules of x into v. So here we have d square plus 2d plus 1 into y equal to x e to the power minus x cos x. Now guys, if you see this linear differential equation with constant coefficient, the right hand side is x into e to the power minus x into cos x. So it means this problem is matching with two different forms. One is x into v. So if I say this is my x, then v becomes e to the power minus x into cos x. So that is the v. That is one form. The second way is I can consider this as e to the power minus x into x cos x. So x cos x becomes my v and this e to the power minus x becomes my e to the power ax. So that becomes the form of e to the power ax into v. So it means this problem can be solved by any of the method. So let's see how to solve it. So first of all, we are going to find out the complementary function from f of d, and then we'll see how to get the particular integral for this question. So this is the auxiliary equation. The roots of this equation is d plus 1 the whole square equal to 0. That is why d is negative 1 and negative 1. And guys, that is why the complementary function, which is also called as yc, is nothing but c1 plus c2 x into e to the power minus x. Now after getting the complementary function, let's move to the particular integral. So particular integral in this case is given by 1 upon f of d, which is d square plus 2d plus 1 into right hand side. So right hand side is x e to the power minus x into cos of x. Now guys, to solve this problem, instead of considering it as x into v, I'm going to consider it as e to the power ax into v, because by doing that we can eliminate this e to the power minus x term first. So here we have the rule which says if you have e to the power ax into v, and in the denominator if you have f of d, we are going to replace that d in f of d by d plus a. Now in our case, our a is minus 1, so we are going to replace this d with d minus 1. So guys, here we will get e to the power minus x term outside into 1 upon d minus 1 the whole square plus 2 times d minus 1 plus 1 into x cos of x. So guys, this is one way, and the other is x into v. So if you want, you can start with that method also, but by using this e to the power ax into v method first, you can get answer easily, hence I am using this method. So here we will have particular integral as e to the power minus x into 1 upon, let's expand the bracket. So here you will get d square minus 2d plus 1, here 2d minus 2 plus 1. So then here we have x into cos of x. Now let's cancel the opposite term. So 2d and minus 2d will be cancelled. This minus 2 and this 1 and 1 2, it will be cancelled. So we'll get only d square. So guys, here we'll write e to the power minus x into 1 upon d square into x cos of x. Now here we have function of d which is d square, and here we have x into cos of x which is x into v. So if we have x into v, we are going to use the rule of x into v. So here is the rule of x into v. So if we have x into v, the answer is given by x minus f dash of d upon f of d into 1 upon f of d into v. So guys, here we'll say it is e to the power minus x in bracket x minus f dash of d. So derivative of this d square is 2d upon d square into 1 upon d square into cos of x. So v is cos of x. Now guys, let's solve this. So this will become e to the power minus x in bracket x minus 2 upon d. So here I have cancelled 1d. Now 1 upon d square. So guys, d is a derivative. So 1 upon d becomes integration. But 1 upon d square means it is double integral. So it means I am going to integrate cos x twice with respect to x. So first time I'll keep 1 upon d as it is and I'll apply 1d, that is 1 upon d on cos of x. So 1 upon d is integration of cos of x is sine of x. So here we will get sine x. Next, here we'll get e to the power minus x minus 2 by d. Now again 1 upon d, that is integration of sine of x, which is negative cos of x. Now we'll multiply this bracket with negative cos of x. So we'll get particular integral as e to the power minus x in bracket minus x cos of x. So this is the multiplication of x and minus cos x. Then here we'll get minus minus plus 2 upon d into cos x. So plus 2 into 1 upon d into cos of x. And now we'll again find out the integration of cos of x because 1 upon d is integration. So here we will get e to the power minus x cos x, and the integration of cos of x is sine of x. So we'll get plus 2 sine of x. And guys, this is the value of particular integral. So it means we got the complementary function and we got the particular integral. So the last step is we are going to put these two values here in this formula to get the final solution of y. And guys, this is the answer of given differential equation. So I'm sure that you understood the method which I've explained you just now, and you understood how to apply this e to the power x into v rule and x into v rule if there are three terms. And guys, if you want to learn such more videos, then keep watching Ekeeda channel because this is the place where you can get all engineering lectures under one roof. Also, don't forget to subscribe to Ekeeda channel and don't forget to press on the bell icon because then only you will get updates about the new videos that we are posting every day. Thank you very much. Keep watching the videos.